Hello everyone, this is Dr. Feng Wang from my home. Today we are going to review some reactions we learned from carbonyl molecules. Again, carbonyl molecules are a really big chunk of organic chemistry. So this is true for real-world organic synthesis. We used a lot of carbonyl molecules to make different organic molecules, either drug molecules or molecules for different applications. They are really, really useful molecules to build um, very useful organic molecules. We learned some carbonyl compounds reaction last semester, and we learn much more this semester. And in the next about 20 minutes, I'm going to review the reactions from all the carbonyl compound molecules. And hopefully this short review helps you understand the reactions of all carbonyl molecules. Well, this is a reaction we learned from OChem1, but this is the enolate formation reaction. So this is carbonyl molecules and alpha hydrogen. Whenever you see carbonyl molecules, pay attention to the carbonyl carbon and pay attention to the alpha position, because the alpha position, alpha hydrogen, has some acidity. If you have a very strong base LDE, you can depronate this oxygen. Sometimes even not a super strong base can also depronate this hydrogen. So at extremely low temperature, we are going to form a kinetic product. At relatively high temperature, we have a thermodynamic product. Why we have two different products. This is what we learned in OChem1. So if you don't fully understand at this moment, I would suggest you to review what we learned in OChem1. I believe this is chapter 21. So whenever enolate is formed, enolate either kinetic or thermodynamic enolate, they are very strong nucleophiles. So if we have an alkyl halide, basically this carbon bears positive charge. Due to the halogen here, they are going to attack this carbon to do like a SN2 reaction to form a new organic molecules. So alpha hard carbon is a very critical position for all carbonyl compound. We can do a lot of reactions from the alpha carbon. So the secondary reaction also from the alpha carbon, basically this is a malonic ester synthesis, two steps. The malonic ester synthesis. This molecule is called malonic ester. So malonic ester basically is CH2 is attached to two esters. So this group could be ethyl or methyl or other alkyl groups. But this is the key structure. The key is this position. This carbon is the alpha position of the two carbonyl groups. So this hydrogen, the two hydrogen here, have a decent acidity. If we have a base, sodium ethoxide, we can depronate the one of the two hydrogen to form an enolate, carbon anion, with a negative charge here. So the next step, if we have an alkyl halide like a bromoethyl, so the enolate is going to attack this carbon to form a new molecule. You see, this is a new structure. Basically, the 1, 2, 2 carbons replaced, ethyl group replaced one of the hydrogen here, where this two-step reaction. So at this moment, we still have one hydrogen. I hope you can see there is one hydrogen here. This hydrogen is still at the alpha position of the two carbonyl groups here. So we can use the base to depronate this this carbon to form an enolate. And if we have a second alkyl halide, this is alkyl halide, we can basically introduce the second alkyl group to the alpha position. So now we have double esters. They are at the beta or at the beta position. If this is ester, this is beta ester. If this is ester, this is also a beta ester. So two esters, we can hydrolyze the two esters and the acid condition. Two esters forms two acid. Because the two acid, they are at the beta position of each other. So if we hit this beta hydroxyl groups, we can actually decarboxylate one of the beta carboxylic groups to generate a single acid. So one of the acid group at this position, see, this is acid, this is acid, two acid, diacid. But when we hit the diacid at the beta position, one of them will be gone. So to eventually we form a single carboxylic acid. Again, this is a reaction we learned in OChem 1. And I want to review more about carbonyl compounds. Again, I hope this quick review help you to refresh most of the reaction we learned. Again, for carbonyl compound, we need to pay attention to this carbonyl carbon because it bears positive charge. We need to pay attention to this alpha position. Alpha hydrogen has some acidity. It can react with the bases. Well, the first reagent, actually group of reagent, these are the organometallic reagent. We learned lithium reagent, magnesium reagent, and acetylide agent. These are all supernucleophiles. In this case, they are also strong bases, but whenever we see strong organometallic, basically these three, for this moment, you only need to know these three. So at this moment, we need to pay attention to this carbonyl carbon. It's going to react with this carbonyl carbon to do reaction. So forget about this alpha hydrogen. Not because they are not going to react to each other, but they prefer to react with this carbonyl carbon. I believe I explained you this in chapter 17. So the cuprate reagents, it is not as strong as the lithium reagent or magnesium reagent. So the cuprate reagent has some special unique reactions like to alpha beta unsaturated carbonyl compound. It can react with epoxy. Oh, sorry, I made a mistake. This is not a cyclic propane. This is should be oxygen. Should be oxygen here. Epoxide, because the strength of epoxide is so strong that even this is not a very strong nucleophile. It still can react with the epoxide. Again, these are the reactions we learned in chapter 17. If we have a strong base, LDA or tertiary butoxide, both of them are very strong base, but they are very, very nucleophile. Base prefer to react with acid. This hydrogen basically is acid. They are not going to react with this carbonyl carbon because the carbonyl carbon is kind of in the center of a cage. It's hard for this bulky. These are really bulky. I call them tone. They are very bulky. It's hard for them to attack the carbon in the center, in the cage. But this hydrogen is on the surface of the organic molecule. So they are strong bases. They prefer to react with this hydrogen to form an enolate, and then the enolate serves the strong nucleophile to react with the other reagent. Another strong base. So this is a difficult. These are very strong base. These are also very strong nucleophile. So if we have this kind of strong nucleophile, strong base, we have carbonyl molecules. So at this moment or at this stage, I strongly recommend you to just react with the alpha position, alpha hydrogen. This are just a surface of the base, not a nucleophile, to attack this carbonyl carbon. Again, not because they don't react at all, but because the reaction product is just not very stable. So they prefer to react with the acid hydrogen here. That's why whenever you see the strong base, strong nucleophile, I call them Jerry. So think about the acid-base reaction to form an enolate. All right, that's all I have for chapter 22. Again, it's a very short chapter and with a short review of all the carbonyl molecules and most of the carbonyl reactions. So if you have any question, you're welcome to email me or text me. Thank you. See you later.